Hello and welcome to Train Signal. You are watching Network Configuration and Troubleshooting. Our lesson on Internet protocols gave us an introduction to basic networking concepts, network hardware, IP addresses, and ports. That was a necessary foundation for the material that we'll cover next. Many times in your career, you'll inherit a network, hopefully a secure, efficient, reasonably smooth functioning one. But that's not always the case. If you're lucky, you'll have an opportunity to install a network from scratch. But in either case, whether it's adding new devices or computers to your network, or in the case of troubleshooting, you'll need to have a good understanding of how to configure your network. You can do this configuration from the command line, but as with other processes we've covered, there are GUI tools that can help as well. So in this lesson, we'll talk about the Dynamic Host Configuration Protocol and how to use this tool for network configuration. Then we'll move on to cover static IP addresses, ones that don't change. Next we'll discuss routing and how this traffic director moves traffic around your network internally and externally. We'll also review hostname configuration, as there will be times when you may need to set or change one. And finally, we'll tackle some troubleshooting tools and techniques. Let's begin with Dynamic Host Configuration Protocol on the next slide. Your network needs so many pieces of hardware, software, and services to work together seamlessly behind the scenes so that it appears to be a ubiquitously functioning system. In order for this to happen, though, you need a little help. Linux provides this help in the form of Dynamic Host Configuration Protocol, or DHCP. DHCP is a server, but can also function as a client. Once configured, it handles all the tough work for you. It doles out IP addresses, subnet masks, gateway router addresses, and domain name server addresses to client workstations in response to the broadcast message they send just as they boot up onto the network. You configure your DHCP server with a range of IP addresses that it can assign to your network hosts. When it receives a request, it responds using the client's MAC address, or its hardware address, and then passes along all the information that allows the two to begin to communicate. Then the client can get itself ready to connect to the network. The server takes an open IP address and assigns it to the host for a set period of time. This is known as a DHCP lease. And when the lease expires, or when the system shuts down, the IP address is released so that it can be reassigned when needed. Now there are three popular DHCP clients, and they include Pump, DH Client, and DHC PCD. And the client, of course, should be run at startup. Now depending on your distribution, this could be a sysv startup script, or for example on our Fedora test system, it uses the etc sysconfig network scripts ifcfg-eth0 file, where ETH0, if you recall, is your network interface, and 0 represents the first adapter. The line that is used to enable DHCP is bootpro in all caps, followed by =, followed by DHCP. You can directly edit this file if you want to, but most administrators choose to use a GUI tool. On Debian distributions like our Ubuntu test system, the file is etc network interfaces, and the setting in this file is iface space eth0 space inet space DHCP. And to run the DHCP client manually, you need root privileges, and you simply type in DH client followed by the device name. Let's open up a terminal window and take a look at a sample DHCP configuration file, then create one of our own. Now to make changes to a DHCP configuration, we'll require root privileges, so let's go ahead and do that first. Type in SU for switch user and your password. Now with every DHCP server installation, there's a sample file included, and let's take a look at that. Let's type in cat space user share doc DHCP asterisk DHCP.conf.sample. Let's Let's make sure we have that typed in correctly. User share doc DHCP asterisk DHCP. I see that we forgot the D. DHCPD.conf.sample. And let's hit enter. Scroll back up to the top. And what you have here is a sample file that's an excellent, well-documentation sample configuration. And what you'll find is that you can actually use some of these lines to create your own configuration file. And again, if you look at each section, it'll document what the settings mean. We have some options here, things that are common to all networks. We've got some lease time. Then we've got dynamic DNS settings, subnet masks. And this is where you can input a range of IP addresses that apply to your network, and some router information as well. Let's take a look at this section. This is for a configuration for an internal subnet. And this should work for our own sample. So let's go ahead and copy this. I'm going to highlight, right click, and select copy. Now we can scroll back down to the bottom of the file. Now let's create our own configuration file. Now on existing networks, this configuration file probably already exists, but I know that on our test system it doesn't, so we're going to create it. So we'll open it up in our Vi text editor by typing Vi space and the path, which is etc. The name of the file is dhcpd.conf, and hit enter. And again, we have an empty file, and the file name is confirmed here. Let's go ahead and hit I for insert mode. Then we're going to paste the information that we just copied by hitting Control Shift and V. And at this point, you would make changes to the file to reflect your own network. For instance, you would have a different subnet and a subnet mask. You'd definitely have a different range of IP addresses and domain names. You'd have your own router information here, including any broadcast information and lease information. But this is our test system. We don't have actually a network with a wide range of IPs and a subnet mask and all of that. But assuming we did, we would go ahead and save the file at this point by hitting Escape, and WQ to write and quit. And at this point, you would restart the daemon. But again, since this is our test system, and we don't have any of the IP address ranges or any of the information that we just included, we don't need to do that. So I will go ahead and remove the file with the rm command, and we'll type in the name of the file, dhcpd.conf. And we'll confirm it with yes. And that's a look at DHCP configuration. Let's go back to the presentation and take a look at static IP addresses. If you have a small network, one less than say 10 or 15 nodes, you may want to use static IP addresses, though this probably isn't a practice that you'll use very often, simply because it becomes difficult to manage. In this configuration, you won't have a DHCP server, so you have to manually set the IPs either using the command line or via configuration files, and those are the same files that we discussed on the previous slide. Required settings in these files include the IP address, which you set via the line IPADDR. Next, you have the net mask, which you set with the net mask line. Gateway address is set with the gateway line. And DNS settings are set in etc resolve.conf. You use the keyword name server followed by the IP address. You can also set the local domain using the domain option in this file. Let's go over to a terminal window and take a look at our configuration files. Let's edit our ifc.fg file to add in a static IP address. We already have root privileges. I'm going to go ahead and clear the screen. Now let's type in Vi. We'll open the file in the Vi editor. Space, etc, sysconfig network dash scripts ifcfg dash eth0. So again, we've got etc sysconfig network dash scripts, I forgot the R, followed by ifcfg dash eth0. And let's hit enter. And you can see that let's go ahead and hit I to enter insert mode. And we've got two commands here already. One that states our device name, which is ETH0, and includes the hardware address. So if we wanted to add in a line to set a static IP address, if you recall from the presentation, we would use, in all caps, IP ADDR equals 68.105.28.12. So that would set a static IP address that would be used each time. And if you wanted to, you could add some additional things here, network mask, broadcast address. Let's go ahead and add a net mask. We'll make it a pretty standard 255.255.255. Whoops, one too many fives. .0. And if we were happy with that configuration, we would go ahead and save this, hit escape, then hit colon, WQ, which we're still in caps, let's take that off, WQ to save and quit. The ifconfig command can be used to configure IP addresses and net mask settings, and can also be used to display your current settings. The command syntax is ifconfig space interface space up followed by the address space net mask followed by the actual network mask. This will set things up just fine for local networks, but if you need to route traffic outside of that network, for instance to the internet, you use the route command. And the syntax is route space add space default followed by the gateway followed by IP address. Let's head back over to our terminal and try out these commands. Okay, I'm going to clear the screen. Now, using the syntax from the slide, we're going to type in ifconfig followed by the interface. So we'll type in ifconfig space interface, which for me is ETH0. And hit enter. And what we see here is the hardware address. Then we've got some broadcast information, IP address information, and we've got packet information, collisions, and byte counts. Now let's try out the route command. Let's just type in route with no options and hit enter. And this displays the routing table. You have a destination, you have a gateway, net mask, and some flags and other information here. Okay, let's go back to our presentation and talk about configuring routing on our next slide. We just learned that routers are used to send information to outside networks. Providing a client with the router address gives you this functionality. To reach a destination on the internet might actually involve 10 or 12 or even more routers. Each keeps track of rules that tell it where to send data. Linux itself can even function as a router. We previously used the route command with no options in order to check out our routing table, but the full command syntax is route followed by add or delete, whichever one you want to do. Then you have net, which is used to indicate a network address or a host if it's a computer, followed by net mask, which sets the net mask, and GW, which sets the router, and this is where packets to the specified target should go. Reject installs a route which should block traffic for the indicated network. Dev is used to specify the interface or the network card. Now, when using this command, you should be very careful, as inputting an incorrect routes could bring your network traffic to a standstill. Let's head back to the terminal and take a quick look at the route command. Okay, I've cleared our terminal window. And let's try typing in a sample route command. Let's type in route space add, since we're going to add a new route. Then we're going to use the -net option, which indicates a network address, and if you recall, -host will be used for computer. So for a network address, let's just type in 192.168.0.0. Then space. Then for the net mask option, I'm going to say 255.255.255.0. And let's end it with the device name, which is ETH0. Now don't hit the enter key. If you recall from the presentation, inputting an incorrect route can cause your system to stop functioning and stop reacting to commands. So you don't want to hit enter unless you're sure you have a correct network address and also a correct net mask. So we're not going to hit enter. We just wanted to demonstrate here the format of the command. So let's go back. If we had entered that route and we found that it was incorrect, once we got our system back up, we would type in the route delete command, which again is route space del for delete, and you would essentially follow that up with the same information, -net, which would indicate the network address, which we input as 192.168.0.0. We had a net mask of all 255s, 255, 255, 255.0. And our device again is ETH0. So again, just examining the command, it's route del followed by any of the options that you set with the initial command. And in our example, we set the network address for 192.168.0.0, and we had set the net mask accordingly and indicated the device name. Again, I'll caution just to be careful with using the route command unless you're absolutely certain you have the correct network address, the host address, and also the net mask. Okay? We'll go ahead and take that out and head back to the presentation. Now that you know how to configure routing, if you want Linux itself to act as a router, you have to enable it. To do so, you use the command at the command line, echo space the number 1 in quotes, then you have the greater than redirector, followed by proc sys net IPv4 IP_forward. And again, you can enter this command at the command line to enable routing. But if you want to make the change permanent, you need to, of course, edit a configuration file. And the file is etc sysctl.conf. In this file, you have to include the command net.ipv4.IP_forward equals 1. Now let's go back to the terminal and try out router enablement. In order to enable routing temporarily, we must edit the IP_forward file and change the option from 0 to 1. To do that at the command line, we use the echo command, which is echo. Again, make sure you still have root privileges. We'll type in echo space the number 1 in quotes space greater than redirector space, and then we put in the full path to the file, which is proc sys net IPv4, and the name of the file again is IP_forward. Let's make sure we've typed that in correctly. We've got echo the number 1 to enable, and again 0 is the current setting, which is disabled. We have the greater than sign, then we've got the path proc sys net IPv4 and IP_forward. Now when you hit enter here, you're not really going to see anything happen, but that will make the change again temporarily. So go ahead and hit enter. And we know that that's temporary, so once the system is rebooted, that change is gone. And that in order to make the change permanent, again, we have to edit another file, configuration file, and that file is sysctl.conf. So let's take a quick look at that. Type in vi space etc sysctl.conf and hit enter. And we see the setting just a few lines down here, net.ipv4.ip_forward, and we see that that's set to 0 currently, which is disabled. And again, if we wanted to enable forwarding, we would hit I to go into insert mode, and we would change that to a number 1. And if you were sure of that change and wanted to save it, you would again hit the escape key and then type in :WQ to save, and the setting would be permanent. We're going to, though, go ahead and change that back to a 0, or by contrast, if you left it a 1 and hit escape and just typed in a colon, a Q, and the exclamation point, that would say to quit without saving. Now we've talked about both the ifconfig and the route command, but there are two additional tools that combine their functionality, and they are ifup and ifdown. Ifup is used to initialize or bring up an interface, and it uses the syntax ifup followed by the device. For example, ifup space ETH0. Ifdown does the opposite and brings the device down, and it follows the syntax ifdown space device. Now when you're troubleshooting, which we'll cover in a moment, being able to quickly take the network up or down can really come in handy. And so far, we've used the command line to handle configuration, largely because this is what you'll need to know for the Linux Plus certification exam. But there is, of course, a GUI option under Fedora, and it's called Network Configuration. Let's go back over to our test system and take a look at this. Click on System, Preferences, and we scroll down to Network Connections. And in the tool that comes up, we see that we have a wired tab, which includes our device ETH0. Then we have a wireless tab. If you had a wireless connection, that would show up here. You've got mobile broadband, you've got VPN, and DSL. Let's head back to wired. From here, you could add a device by clicking on the Add command. You have the option to have it connect automatically, which is probably a good idea. You can name the connection, input a MAC address, decide whether to make it available to all users, and you have some MTU information as well. You've got security options, IPv4, and if your network uses IPv6, you can set options for that here as well. I'm going to cancel out of there. And if we just click on our existing device, you can either delete it from here or edit it. And again, we have the MAC address that you could change if you needed to, although I don't see why you would need to do that. You have the connection options. You've got security options here that you can enable, and again, IPv4 or IPv6 settings. Okay, I'm going to go ahead and close out of there. And we're going to bring our terminal window back up. I'm going to clear this window. I'm going to type in ifconfig again, just to start. And you can see here the iNet address. Just make a note of that. Now we're going to take the network down with the ifdown command. We need to obtain root privileges. So let's type in SU for switch user and hit enter, then enter our root password. Okay, now we're going to type in ifdown space ETH0 and hit enter. And we can see now that the device says disconnected. Let's type in ifconfig again and hit enter. And you can see that we no longer have that IP address that was here. Let's also type in route and hit enter. And you can see that again we don't have any routing table information because the card is no longer enabled. So let's bring it back up using the if up command. So we type in if up, and we know the device name is ETH0. And hit enter. And we see here that the connection has indeed been activated. Let's try ifconfig one more time. Use the up arrow and hit enter. And you can see again we've got an IP address. Okay, let's head back to the presentation and review hostname configuration. We know that host names are just names for the computers on your network. But what we haven't talked about yet is how to configure them. You can do this one of two ways. The first is with DNS, or Domain Name System. With this option, you add an entry to the DNS server, or alternatively, you could edit Remote Systems etc host file, which probably isn't the most practical option. The second way to configure a host name is locally. Now technically this name could be different from the DNS host name, but it's probably not the best idea in the world, as this could easily lead to a lot of confusion. To set the host name on your local computer, you use the command hostname followed by the name of the host. Now those are the two options for hostname. By default, Linux will go to the etc host file for lookups before turning to DNS. You can change this in the etc nsswitch.conf file. On the host line, you simply will change the syntax to read host : space files space DNS. If you want to set your domain name, you use the command domain name. Now this sets the domain name as used by the Network Information System, or NIS. DNS domain name, by contrast, sets the domain name used by DNS. Both of these commands, though, can also be used to display your current domain name. Most distributions will look at the file etc hostname first to figure out how to set the hostname. So any changes that you want to make that you wish to be permanent have to be made to that file. On our Fedora test system, that file is etc sysconfig network instead. Let's go back to the terminal and take a look at our configuration files. Now let's see if we have a host file. Let's type in cat space etc host and hit enter. Okay, and you can see that we have the IP followed by the host name. Then we have the first one for the host that's Veronica. Then we have the second one that's for localhost. Now let's take a look and see if we have the other file that is typically available on Fedora systems. Let's type in cat space etc sysconfig network. Cat etc sysconfig network and hit enter. And you can see we have two settings here, networking equals yes, and the host name again is Veronica, which we see right here. Let's take a look at how to change the DNS lookup order. From our terminal window, we'll need root privileges, so let's type in SU, and type in your password. And from here we're going to use the vi editor, so we'll type in vi space and the name of the file, which is etc nsswitch.conf. Let's make sure we have that spelled correctly, nsswitch.conf. And let's go ahead and hit enter. Okay, then let's go into insert mode with I, and we'll scroll down to the host line. And as you can see here, we have the current setup where we have files, we've got some other information, and we've got DNS on the end. So this is the line that you would change. So say for instance you wanted to have DNS first, you would type DNS and then just leave file second. We'll go ahead and leave it just as is, but if you wanted to make the change, here's where you would do so. Then you would hit escape to enter command mode, and from here you would type in colon, and if you wanted to make the change, then you would type in WQ to save and quit. But for our purposes, I'm just going to type in Q and the exclamation point to exit. Think about where you spend the majority of your time as an administrator. I'm guessing troubleshooting. Luckily, Linux has several tools to help with this most important task. One that you're probably already familiar with is Ping. This is a tool that's used to test connectivity between hosts. Ping works by sending an ICMP echo request packet from the source system to the destination, and it does so every second or so until you hit Control-C. The destination system responds with an echo response packet. Now, if you don't want to hit Control-C to stop the output, you can use the ping command with the -C option, which tells it how many packets to send. For example, the command ping space -C space 5 followed by linux.com would ping linux.com and ask it to send back 5 packets. The only problem with ping is that sometimes firewalls can block ICMP requests, so keep that in mind before deciding if a system is really down or not. The next command is traceroute, and this works by sending 3 packets to each computer that sits between your system and the target system. The -N option says to show the target computer's IP instead of the host name. Tracepath is a similar command, but it gives you one line of output for each test packet, and this can make the output a little longer. Let's type in ping, and we're going to do the -C option, and let's look at 5 packets, and we'll type in trainsignal.com. You can put in any host or network computer here, and again we're going to ping trainsignal.com and ask for 5 packets using the -C option, and let's hit enter. It should go out and ping train signal 5 times. It'll come back and tell us how much time it took. We've got 59.7 milliseconds and all the way up to 58.1 milliseconds. Not too bad. And again, ping just confirms that we have an outside connection and tells us the speed at which it's working. Now let's try traceroute. Type in traceroute followed by the host or the network. We'll try trainsignal.com again. And hit enter. And what you can see there is a bunch of asterisks. Let's go ahead and Control-C. What you'll find is that some systems actually block traceroute and tracepath data. So if you see the asterisk there, that kind of confirms it. Let's try tracepath really quickly. We'll type in tracepath and we'll do trainsignal.com again. And as you can see, we're getting no replies. Let's go ahead and stop here. Let's do something internal just for test purposes. So let's try tracepath. We're going to use the IP that you see right here, which is mine. So let's go ahead and type in 10.0.2.15 and hit enter. And this time we got a result. Tells you how many milliseconds it took to complete the transaction and tells you the starting point here. Okay, back to the presentation. Continuing with troubleshooting, all the commands we discussed on the previous slide are worthy additions to your support toolkit. However, there is one tool that just may do the work of them all, and that tool is Netstat. Among Netstat's talents are the ability to list network connections, display the routing table, and it also displays information about your network interface. The Netstat command has several options. The first is --interface or -I, which shows information about the adapter, sort of like the ifconfig command. --route or -R shows the routing table, just like the route command would. --masquerade or -M will obtain information about the connection using NAT features. NAT features use the name IP masquerading. This is useful for networks with limited numbers of IPs. Next we have --program or -p, which gives you information about programs using network connections. --all or -a is used in conjunction with the other options and will give you information about the ports that server programs open in order to listen for network connections. Used with no options, netstat returns information about open ports and where they connect. Let's go to the terminal and try out some of these commands. Now let's try typing in netstat with no options. And hit enter. And you can see in this long listing we have port numbers over here and where they connect in this column. Pretty long listing. Okay, let's now try netstat with the interface option. I just use the up arrow to bring up the command, and I'm going to type in --interface. You could also use the -I and hit enter. And here we have adapter information. You can see ETH0 and some other information associated with that. Now let's try the -R option. Use the up arrow key, and I'm going to include -R. And this should look familiar. This is the same information that we would get if we just typed in the route command. So we have routing information here. Destination, gateway, subnet mask, etc. Now let's try the -M option. Again, that's for masquerading. And as you can see, we don't have any support for masquerade on this system. Again, if we had a network with a limited number of IPs and we might want to implement that, using the -M option could give you information about how masquerading is set up on your system. Okay, now let's head back to the presentation. We've got a few more troubleshooting tools to talk about. To look at raw traffic on your network, you use the command tcpdump. This tool is a packet sniffer, which intercepts network packets and logs them or displays them on the screen. Now you have to run this command as root, and like ping, you have to use Control-C to end the output. And you can also use -C space num as an option to specify the number of packets and then quit. tcpdump also takes the following options: -A to display the output in ASCII format, -D to show the interfaces, -N displays addresses numerically, -V or verbose is used to display additional information, and you can also use -VV or -VVV for even more information. And then we've got -W space file, which writes the packets to a file that you specify. Then we have other tools like Telnet and FTP, which are mainly remote login tools. But in a pinch, they can also act as debugging tools. With Telnet, you type in the name Telnet followed by the system you want to connect to. Then you log in at the prompt. But if you add a network port number after the system name, it'll connect to the server that uses that port. You can then enter commands to see if the system is running properly. As far as FTP, it lets you log into a remote system and transfer files. And like Telnet, you enter the command FTP followed by the host name. Transferring files will yield information that helps you track your network's transfer speeds. But I'd like to add a word of caution about Telnet and FTP. These aren't secure protocols, and data transferred using these methods isn't encrypted. If SSH does the exact same thing, you're much better off using this protocol. But for certification purposes, you should have an understanding of both of these tools. Let's go back to our terminal and try out the tcpdump command. Okay, in order to use tcpdump, we have to have root privileges. So make sure that you're still logged in as root. If not, go ahead and do so now. Now we're going to type in tcpdump with no options and hit enter. Now again, this is a program that looks at data that's going across the network, and right now not a lot is happening. So let's go ahead and launch Firefox. Then take a look at our output. And now that we see output is coming through, and this again is actually raw data that's traveling across the network. And again, if we want to stop this, we have to hit Control-C. And we can see that we had 22 packets captured, 22 received, and 0 dropped. Now let's type in TCP dump with the -A option. I'm going to close out Firefox, and then we're going to go ahead and launch it again. And if we minimize that, again we can see the output again, and that the output is stopped. The -A option, if you've noticed, is used again to display the information in ASCII format. Let's hit Control-C. Now let's use the TCP dump with -D to take a look at the interface information. Again, I use the up arrow to bring the command back up. Let's go ahead and hit Enter. And here we have some interface information. We've got our ETH0, some USB port information, etc. Now let's try TCP dump with the N option, which should display information numerically. So we're going to use the up arrow to bring it back up, and we're going to substitute in the N. Let's go back to our Firefox window and click on something new so we can load some new information. Let's minimize that. And again, here you can see we don't have names anymore. We actually have numeric information, as indicated with the -N option. Okay, I'm going to go ahead and Control-C to stop that here. We've got 10 packets captured, and 10 received, and 0 dropped. And that concludes our lesson on network configuration and troubleshooting. Let's go back to the presentation and review what we've learned on the next slide. Though you can, and often will, configure your Linux network during installation, we know that no network is static. The time will come when you need to reconfigure a setting or troubleshoot network problems. So in this lesson, we learned that Dynamic Host Configuration Protocol can be used to automatically configure network clients as they boot up. And for those instances where you want to use static IP addresses on your network, we learned how to alter the necessary configuration file to do so. Then we talked about routing and how to configure routing tables to help enable communication outside your local network. Next, we covered host names that identify systems on your network and how to manually configure your network interfaces. We wrapped up this lesson with a look at Linux's troubleshooting tools designed to help diagnose issues that may be plaguing your networks. Thanks for watching, and I'll see you in the next lesson.